Okay, we're going to go through partial fraction decomposition today, 7.3. We're first going to talk about if our original fraction that we're working with has a denominator that has linear factors in it. And then later we'll talk about if the denominator has quadratic factors in it. So for right now, we're just going to go over case 1 and case 2, where they have linear factors. The first case we're going to look at is distinct linear factors. What that means is I have x minus 5 and x minus 3 in this first denominator. And those are different. They're distinct. Whereas in case 2, repeated linear factors, I have an x minus 5 here in the denominator. And I have an x plus 3, which is different, so it's distinct. But there are 2 copies of that x plus 3. So that's going to get 2 more fractions. So I have a total of 3 fractions for this one. One for the x minus 5, and the x plus 3 is going to get 2 fractions, one with 1 copy of x plus 3, and the other ones can have 2 copies of x plus 3. So let's see what that looks like and how we continue that process afterwards. Notice my numerators are just alphabet variables. If I had more fractions, I would continue on with D, E, F, so on and so forth. There are steps here that you can read through. If you'd like to go back and read through these steps, I'll actually talk about them as we go through the process for the first couple of examples. Step 1, I need to set up the partial fraction decomposition with unknown constants A, B, and C. I see that my denominator here has 2 distinct linear factors. There's an x to the first power, x to the first power, that makes them linear factors. So I'm going to write 2 separate fractions for these to separate out those 2 denominators that I have. The first fraction is going to have a denominator of the factor x minus 3. I'm going to put a plus sign between the 2 fractions, and the next one's going to have a denominator of the factor x plus 4. I am then going to go ahead and put in the numerator variables. I don't know what the numerators are yet. Those are actually my unknowns. So I'm just going to start with the alphabet A, and then I'm going to continue to the alphabet B, so on and so forth. Now, I want to find out what A and B are so that I can then write this as a final answer, denominator of x minus 3 plus denominator of x plus 4. I'll find out what A and B are in a minute, and I'll substitute them back in here, and this will be my final answer with the values that I find for whatever A is and whatever B is. Okay, so how do I find those? I need to build a system of equations to find out what A and B are. A and B will be my variables. Okay, how am I going to do that is I'm going to consider step 2. I'm going to rewrite these equations so that they have the least common denominator. So right now, this has a denominator of x minus 3. I'm going to need to multiply the numerator and the denominator by x plus 4 to get that common denominator of x minus 3 times x plus 4. So I'm going to go ahead and multiply that on. X plus 4 in the denominator, which means I need to multiply x plus 4 in the numerator. The second one has an x plus 4, so I'm going to need to multiply on an x minus 3 in the denominator, which means I also need an x minus 3 in the numerator. Now, all 3 of these fractions, the original one, and now the 2 fractions that I built, they all have that common denominator. So when they all have that common denominator, I can really just forget the denominators and work only in the numerators. An example of that, I'm going to erase this. If I would have 1/5 plus x fifths gives me 7/5, I know that I have to add on 6/5 here to have 1/5 plus 6/5 to give me 7/5. I didn't actually need the denominator 5 to figure out that x needs to be 6. So once the denominators are common, all the same, you can work in just your numerators. So I'm going to write out my numerator as 5x minus 1 equals a times x plus 4 plus b times x minus 3. I'm going to now go ahead and work on the right-hand side. This is step 3 of the equation to distribute and combine all of my like terms. So I have 5x minus 1 equals a times x, which I write as ax, and then a times 4, which I write as plus 4a. Or you could write a4, that's fine. I then have a positive b times x, so plus bx. And then a positive b times negative 3 ends up being negative 3b. There are like terms here. And you're going to go with the degree of your x's to build your rows based on those like terms. So if I had x cubes in here, I would have a row of x cubes. And then I would go to a row of x squareds, and then to a row of x to the first, and then a row of just the constants, the number that stands alone. Okay. I only have x to the first in constants here, so I would only have 2 rows for the system. And so I'm going to start off with my x row. So my x to the first row, I look for any terms that have x in it. So there's a 5x, an ax, and a plus bx. I don't want to include the x's because I could divide x on both sides of the equation. I'm going to erase this in a second. 5x equals ax plus bx. Well, I could really just divide all of this by x and get rid of all those x's. And I have just 5 equals a plus b. So instead of doing that extra work, I'm just going to drop the x's. And instead of writing 5 equals a plus b, I like my system to have my unknowns on the left-hand side, a plus b, and my constant term of 5 on the right-hand side. So we kind of flip-flop these as we write them. This goes to the right-hand side, and anything on this side goes over here to the left-hand side. Okay, so let's record that now. I have a with an x plus b with an x would be equal to 5 with an x, but I dropped my x's. And then I'm going to look at my constants. I have a negative 1, a 4a, and a negative 3b. I can't divide out a or divide out b and get rid of all of them, so I need all of that. On the right-hand side, I have a negative 1. Remember, this is going to the right-hand side. And then the left-hand side, I'm going to record that 4a minus 3b over here on the left-hand side in the respective columns. So this is my number column, the constants that stood alone with no x's in them. This is a system of equations, and I can take this system that has 2 rows by 3 columns, and I can write an augmented matrix from it. I'll have an A column, a B column, and a number column. So I have 1a plus 1b equals 5. 4a minus 3b equals negative 1. So my augmented matrix has unknowns for a and b, which is what I want to find. What is a and b? We're not going to put this in our graphing calculator together here. You're just going to write down what I have. We would put that in our graphing calculator. We would run the row reduced echelon form on it, RREF, and our calculator would take us to the identity matrix on the left, 1, 0, 0, 1. There's this imaginary line that's not really on your calculator, but that separates out your solution, and it would give you a column of 2 and 3. And that column corresponds to your A value and your B value. So then I can replace this first numerator A with a 2, and the next numerator B with a 3 to have my final answer here. All right, let's move on to the next question. I have it's a quadratic denominator. And we're just working on linear denominators right now. Well, I would see if I could factor that to get linear factors as my denominator. So x squared plus 2x minus 3 is 3 terms. I'm going to write that as a guess and check. X times x multiplies to x squared. 3 times 1 multiplies to the 3. A positive 3x here, so I'm going to put a plus sign. And then a negative 1x here would get me back to my 2x. And then 3 times negative 1 is a negative. So these are good factors. And I'm so happy because I don't have to work with quadratic factors yet. These are both x to the first power linear factors. I take this denominator and separate it out to 2 fractions since I have 2 factors and none of them are repeated. So my 2 distinct factors will end up being 2 distinct denominators. First one with x plus 3 plus second one with x minus 1. And again, I'll start the alphabet with A and then move forward to B. And then I like to go ahead and set up my final answer. So I know I'm going to find out what A and B are, and I'm going to write the A over my x plus 3 plus whatever I get for B over my x minus 1. That way I know what my end goal is. I'm trying to solve for A and B. So then I start with that system. I want a common denominator, so x plus 3 needs to be multiplied by x minus 1 on the top and the bottom. X minus 1 needs to be multiplied by x plus 3 on the top and the bottom. I have the common denominator in all three of my fractions, so now I can forget the denominators and write out the numerator. I have just x on the left-hand side, but I'm going to go ahead and put plus 0 to hold the place of the constant term, equals a times the x minus 1 plus b times the x plus 3. I'm going to distribute through the right-hand side, so I have x plus 0 equals ax minus a, after I distribute the a to those two terms. And then I have plus bx plus 3b after I distribute my b through those two terms. At this point then, I'm going to do this process where I take off my x terms and write them as a row, and take off my constant terms and write them as a row. This process right here. Okay, so I'm going to start with x's. I have x values of x, ax, and bx. And again, for that x, the first power row, I'm not going to write the x's. This is going to go to the right-hand side as a 1, because there's just one x there across the equal sign. And then this ax plus bx is going to record over here as a plus b. Now I'm going to move to my constants. So my constants are the terms that stand alone. There are no x's with them. And so I have a 0 here that's going to record to the right-hand side. So there's an equal 0. And then I have a minus a plus 3b that all needs to be recorded here on the left-hand side in respective columns, minus a plus 3b. Again, I have 2 rows and 3 columns. So I'm going to write that 2 by 3 augmented matrix. 1a plus 1b equals the number 1. Negative 1a plus 3b equals the number 0. I would put that into my calculator. I would run the RREF on that matrix. The RREF is going to give us our identity matrix on the left, 1, 0, 0, 1. And on the right-hand side, it's going to record for us our solutions. They're going to be decimals, so you can hit a math button. And then number 1 turns it back into a fraction. And then it will turn those decimal values into the fractions 3/4 and 1/4. Which you might recognize those decimals, 0.75 and 0.25. All right, so these represent my A and my B, but they're a little bit different because they're fractions. So I'm going to have to do a little bit of prep work before I write my final answer. I have A of 3/4. I'm going to write that down here. And that's over my x plus 3. And then I have plus a b value of 1/4. That's over my factor x minus 1. Well, we don't like to see ugly fractions like this. That's why I call them ugly fractions. They're actually compound fractions, fractions within fractions. So instead of dividing, we multiply by the reciprocal. So this 3/4 here is going to be, instead of dividing, it's going to multiply by the reciprocal of this fraction. Well, this is a fraction. You can put anything over 1. So I'm going to multiply this by 1 over x plus 3. And then again, I'm going to take the 1/4 in the numerator. Instead of dividing here, I'm going to multiply by this fraction's reciprocal. So I put that over 1, reciprocate that to 1 over x minus 1. And the way we multiply fractions is we multiply the numerators. 3 times 1 is 3. Over denominator, 4 times x plus 3. And you can just write that as 4 times x plus 3, unless it says to simplify. And then you would need to simplify that to 3 over 4x plus 12. I have plus 1 times 1 is 1 over 4 times x minus 1, 4 parentheses, x minus 1. Or I could distribute that to be plus 1 over 4x minus 4. On the test and quiz, you do not have to simplify it. So I would take this answer. I expect you to not spend your extra time distributing it. Give me this answer. And so look what happened. That 3/4 just went to a numerator 3, denominator 4, with that denominator x plus 3 already sitting there. And again, the 1/4 went to a numerator 1, denominator 4, with the factor that's sitting there. And that will always happen. So instead of doing all of this work that we just did, if you recognize that, you can just write your final answer up here as numerator 3 times denominator 4 multiplied to that x plus 3, and then numerator 1 over denominator 4 times that x minus 1. All right, the last one that we're going to do here then is this number 3 that has a factor of x. This one's hard to see. Just a second, let me scrunch this down out of our way. Okay, has a denominator of x for a factor. That's a distinct factor, so I'm going to go ahead and write that as a denominator of x. That has a numerator of just a. And then for my next denominator, I have 2 copies of x plus 7. That's not a quadratic factor. That is a linear factor. It's x to the first power. So it's a linear factor. There's just 2 copies of that. So what we do for those repeated factors is we write out those 2 factors as 2 denominators. The first denominator will have just 1 copy of that x plus 7. And the second denominator I'll write as x plus 7 squared. And so it looks like I actually have way too many copies of x plus 7, but you have to remember I'm going to get back to a common denominator. My common denominator will have at most 2 copies of x plus 7, just like this has at most 2 copies of x plus 7. So I'm going to be okay. I'm going to go ahead and record my variables on top as b, and I do get to continue on to c this time. And then I know my final answer is going to have some numerator over x plus some numerator over x plus 7 plus some numerator over x plus 7 quantity squared as my final answer. And so let's find out what a, b, and c are. To work towards getting that common denominator, I need an x, and I need 2 copies of x plus 7. Well, this first numerator has just an x, so I need 2 copies of x plus 7. X plus 7 quantity squared. What you do to the bottom, you do to the top. My next denominator has an x plus 7, 1 copy, but it needs 2 copies. And it also needs an x. So I'm going to have to multiply that by x and another copy of x plus 7 in the numerator and the denominator. And then my last denominator has 2 copies of x plus 7, so it is just missing this factor of x here. So I'm just multiply by x on the top and the bottom. And let's double check. I have x, and now 2 copies of x plus 7. That's the common denominator. X plus 7 and another x plus 7 is the 2 copies, and then the x. That's good. And then 2 copies of x plus 7 and an x. That's good. They all have the exact same denominators, so I can forget the denominators and write out my numerator, 3x squared. It's our first squared term. So we're going to have the first squared row here. I am going to write a plus 0x. So I see that as a 0 on my x row. And then plus 49 equals, and I'm going to actually do a little bit of distribution on this first line here. So this is a times 2 copies of x plus 7. Well, I know that, let's do some scratch work over here on the side. I know that x plus 7 times x plus 7 needs to be distributed. X times x is x squared. X times 7 is plus 7x. Distribute 7 times x is plus 7x. And 7 times 7 is plus 49. So this comes down to x squared plus 14x plus 49. And so that's what a is multiplied to. x squared plus 14x plus 49. My next numerator is plus b, and then b is multiplied to x and x plus 7 here. Right here, b is multiplied to x and x plus 7. So I'm going to go ahead and distribute x to x and get x squared, and then distribute x to 7 and get plus 7x. And that's what b is going to be multiplied, the quantity of x squared plus 7x. And then I have plus c, and c is multiplied to just x. Okay. Let's go and do our distributions on the right-hand side now. I have 3x squared plus 0x plus 49 on the left still equals, distribute a through 3 terms. So ax squared plus 14ax plus 49a. It doesn't matter where you put the a. If you wrote this as 14xa or x squared a, that's fine. It doesn't matter where you put that a. Distribute my b through. I have plus a bx squared plus a b times 7x, so 7bx or b7x, doesn't matter how you write it, and then plus a cx. And we have a new row. We have an x squared row this time. So we are going to write an x squared row by taking out all my x squared terms. I'll go find them all. And remember, as we write that x squared row, we don't have to write the x squared because the x squared is in all of them. It would divide out of all of them. So my x squared row is going to have 3 on the right-hand side of the equal sign. And then my a plus my b is going to go to the left-hand side. Oh, there's no c. So what should I do for the c column? I'm going to write plus 0. Because I do have c's at some time. I need to find out what c is. So I'm building a system of a, b, c equals to a number. All right, next I have a x column that I need to write. The x column would have 0x. There's something that has x in it, 14ax. And there's something that has x in it, 7bx. Oh, and a cx, lots of x's. Okay, so my x to the first power row is going to have this 0x as a 0 on the right-hand side of the equal sign. And then on the left-hand side of the equal sign, I'm going to have my 14a plus 7b plus c. And again, I can do that because they all have x's in them, so x would cancel out of all of them. For my last one, though, the constants, the numbers or the terms that have no x's in them, I can't drop the a, the b, the c. I need those variables. So I just write my constants on my constant row. That's the ones that have no x with it. 49 is going to go on the right-hand side here, equal to 49. And then I only have a 49a going to the left-hand side. So that means I have plus 0 for my b and plus 0 for my c. And I could actually solve that and find out what a is pretty easily. But we're going to go ahead and continue with our systems. So this system is now 3 rows by 4 columns. So I'm going to write that as an augmented matrix with an A, B, C column equal to a number column. I have 1A, 1B, 0C equals 3. I have 14A, 7B, 1C equals 0. And then I have 49A, 0B, 0C equals 49. After I run my RREF with my calculator on this, it is going to give me the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 on the left-hand side with that imaginary line. And then on the right-hand side, it's going to give me the values of 1, 2, and negative 28. Excuse me. And so I know those correspond back to my unknown variables that I'm trying to find. There's my A of 1, there's my B of 2, and there's my C of negative 28. Whoops, C. So up here at the top, where I already have this prepped, I can replace the first term with 1 as the numerator for A. The second term, the second fraction, it's a term. Second term is a 2 in the numerator for B. And then the third one, I can write a negative 28 up there, or I could change that plus sign to a minus 28. Either one is acceptable. When I have two terms in the numerator, which I will later on, I don't want you to try to pull that negative to the front because sometimes it makes errors. So I'm just going to leave that negative 28 in the numerator. I'm just going to leave that plus sign there. Now, if Pearson says simplify, then you might have to pull that minus out to the front because you know they're pretty particular. Okay, we're not going to go into 4 or 5 today. That will be for tomorrow. So you guys are good to go start your homework now.